All right, everyone, welcome to Mastering Cisco SDA. This is the details that make or break deployments. My name is Chris Day, and I'm Principal Consultant at Data3. And before we get started, I wanted to tell everyone a little bit of information about myself. So I am a dual citizen, if you can't tell by the wonderful accent that I have. I'm from the US, and I've been in Australia for nearly 14 years. I did serve 4 years in the US military and all 4 years in Germany, where I grew a love for Bayern München. So you'll notice that on there. And then I've been in the industry for over 25 years. So I have you notice the Novell NetWare over there. I did do earlier versions of NetWare, but that was my favorite one before they went to OES. So 13 years at Data3. My entire time in Australia, I've been at Data3. I'm a CCIE, and I hold 33 other certifications. Those span mostly Cisco and Linux. My passions, football. I used to play a lot of soccer, don't anymore, so now I watch it. I love learning new tech, so as new things come out, I love learning it, learning how to incorporate it into networks and systems. Automation and scripting is a bit of a passion of mine. I love APIs, consuming APIs, using APIs. And then I do a bit of PC gaming and play VR, so I am a kid still at heart. A little bit about Data3. In 2023, 2.5 billion in revenue. We have 9 offices across all of Australia and Fiji. A bunch of other impressive numbers up there for you, but working at Data3 for 13 years, I've seen these numbers increase year over year. It is a fantastic company to work for. So a bit about our current SDA customers. This isn't everyone, this is just what I could fit onto a single slide deck. Right now we have in flight Griffith University. So Griffith University, we're about a month away from finishing that one, and we have replaced every single switch that they have with software-defined networking. This is 5 large campuses with an SDA transit. So those of you that are familiar with SDA and know what a transit is, the transit's been working really well for them. PFD Foods, they got 72 sites. I helped them with their first couple, then I mentored them through a few others, and then they were able to go and take the remaining 72 sites live with SDA. And they replaced an Aruba network with the Cisco SDA network. Public Transport Authority in WA. These guys needed some help with their train system and some fast roaming on the train network, and Cisco SDA was a product that was able to answer that requirement. The Geelong football stadium, so down in Geelong, they redid one of their riser bleachers. We went ahead and put SDA in, replaced an Alcatel network. Now they're going SDA throughout the entire stadium. One that's not listed here that we started that's in flight is MCG. So we are in the design phase with the MCG. So the MCG will be all SDA, and that will be done by Data3. Fremantle Ports we did. And then my very first customer was MYOB. The manager at MYOB was so impressed with the way SDA worked that when we brought the new site live, the opening day, he had his wife bake a cake. So I took photos of the cake. It's great. It's got things about DNA Center and SDA. You see Data3 on there, and they even put my name on the cake. So I've never been part of a project that was so successful. I had a cake baked. So very proud of it, and took photos, and I show it to everybody. I even take it to Christmas parties. So what we're going to be talking about today are the things that are commonly missed when planning an SDA deployment. So I only have 20 minutes. So there's only 4, there's a lot more on here, but these are kind of the 4 common ones that are missed. We're gonna talk a bit about multicast. So we'll learn about the requirements of multicast and how to configure multicast. We're gonna talk a bit about SOE imaging. This is one I've seen a lot of customers struggle with, is imaging. We're gonna talk about Wake on LAN, and then we're gonna finish up with talking about wired authentication strategies. And we're specifically talking about the supplicant configuration on Windows. So to get started with multicast, we go over what have we learned, and we learned that we really need to understand what type of multicast traffic you guys are doing inside of your environment. We know if it's coming from outside the SDA fabric. We know if it's coming from inside the SDA fabric. We also need to know what you need to do within your network. So it might not be multicast related. It might be that you need to use something like Wake on LAN. You might need L2 flooding. You might need IP directed broadcast. So these are things that we need to discover at the very beginning to make sure that your project goes successfully. Because these are the types of things that can really gotcha halfway through a project or even after a project's completed that weren't just not thought about. So what we're going to be talking about is the difference between head-in replication and native multicast configuration. So if you've ever gone through an SDA GUI on the multicast, it talks about, do you want to do head-in or do you want to do native multicast? Head-in replication is extremely easy to set up, but it doesn't support things like multicast across SD transit. It doesn't support that IP-directed broadcast and the L2 flooding. So if we come over here and I take a look at native kind of versus head-in replication, with head-in replication, it's very simple to deploy. There's really no requirements about it. The border node is going to take multicast traffic and it's going to turn it into unicast traffic and deliver it all the way to the fabric edge node. It's going to drop it to the endpoint. This is a lot like wireless. If you've ever done multicast wireless, exact same way wireless works. This is great if there's low multicast use. And the reason I say it's great if there's low multicast use is because there can be a lot of high overhead on this. You're taking multicast packets and you're converting them to unicast. So we end up with a high yield on the border nodes when we're doing that. Now with native, there's a lot more requirements because with native multicast, every single device in the underlay needs to have PIM neighbor relationships. And we need the loopback IP address to also be PIN adjacent as well. So there's a lot of requirements in there for a native multicast, but it uses the underlay and it has low overhead because we're not moving multicast traffic into unicast traffic. It's native multicast. The other thing in here is we have requirements on native multicast, SD transit multicast, IP directed broadcast, L2 flooding. The takeaway that I give to my customers is to just go down the native path. And the reason is you don't know what the future is going to hold for you. And if you're doing native, you're going to be set up to support just about everything. The only place where I would say head-in might make more sense is somewhere like PFD Foods where they have 72 little bitty sites and no SDA transit. It's going to be easy for them, but everywhere else I probably go ahead and do native multicast. The other thing too is when you're doing LAN automation, if you LAN automate your switches, there's a little checkbox during the LAN automation process that says enable multicast. If you enable multicast every single time you do LAN automation, you've taken care of all the hard work. The LAN automation process is going to go ahead and give you that PIM neighbor relationship and it's going to configure the underlay multicast for you. So definitely if you're using LAN automation, you check that box and you're not going to have to go after the fact and configure the multicast natively. Next thing I want to talk about is imaging. There's a couple things to cover in imaging. One of the big issues that customers have is they want to be able to plug in a device. And when they plug that device in, they need to know, are we going to image it or are we going to deny it from the network? So I've come up with a few techniques on how to help us out with discovering that. So if we're in a closed mode authentication, we know that closed mode doesn't allow anything but CDP and 802.1x through. But if this is a device we're imaging, it doesn't have a supplicant, so it's not going to send 802.1x. So what I'll normally do is I'll have my very bottom profile, or my very bottom policy will be a profiling policy that will do a downloadable ACL, and yes, downloadable ACLs are supported in SDA Fabric. It'll be a downloadable ACL that's going to permit DHCP. And they might be in a startup VLAN that doesn't have a DHCP server, but that DHCP information is going to get to ICE. And what I will pull out of the client identifier here is that the DHCP class identifier contains Pixie-client. If it contains Pixie-client, I now know that this device is Pixie booting, and I can go ahead and profile an ICE as a Pixie boot device. So then I can say if it's a Pixie boot device, I need to move it into this VLAN where it can actually get an IP address, and we can allow it to talk to the imaging server, and we give it a Pixie SGT and allow us to apply some policy. I might have another policy too that says if it's been discovered as a non-Pixie device, because ICE profiling is going to say if this doesn't exist and it didn't hit any of the policies above, it's a non-Pixie, so now we're going to block it. And we have effectively done what we want to do in closed mode authentication. We have identified a Pixie boot device and we're able to image it. So that's one piece of the puzzle. The other piece of the puzzle is if you're doing on-premises imaging with SCCM. A lot of customers are not aware of this. If your DHCP is set up to do WDS, so if you're saying go get your WDS file from this distribution point, it does not work in a fabric. You cannot image your devices with WDS in a fabric. So what you need to do is you need to deploy a new distribution point. And when you deploy that new distribution point, you do not check the WS. And as long as it's not supporting WDS, it is now supporting option 82. So as of SCCM release 1906, which would be quite old, if you're not on that, you should definitely be past it by now. That distribution point will now support option 82, and all we need to do is add an extra IP helper to that non-WDS distribution point, and you'll be able to image your machines. We're going to move on to Wake on LAN. So what have we learned with Wake on LAN? Well, when you do your authentication templates inside of the Catalyst Center, you're going to have this option for Wake on LAN, yes or no. And what that's going to do is enable IP-directed broadcast for that authentication template. The other thing that we need to think about is the startup VLAN. Because what happens with Wake on LAN is devices fall asleep and we want to wake them up. If a device falls asleep and you go to that port and you do a show-off session, there's going to be no session information. It's timed out. It's gone. So what happens when there's no session information? Even if it's in closed mode, that port is now in the VLAN that is configured in the switch, which is going to be VLAN 1 by default. VLAN 1 is not going to get the magic packet. You're not going to wake your devices up in VLAN 1. So what we want to do if we're trying to do Wake on LAN is we want to do a startup VLAN that we can actually send a magic packet on. So when the device does go to sleep and it times out, if the switch is configured for VLAN 100, VLAN 1012, whatever that VLAN is, we can send the Wake on LAN packet, the magic packet, we're going to wake the device up. Another thing is if you do have a multi-site SD transit, the configuration does not work in the GUI with a multi-site fabric. So it's not supported, it won't configure the border nodes properly, and what you have to do is you need to get with your Cisco TSA and get a design council approval process going. It takes about 2 days. They don't take very long. And what they will do is they will approve the design and they'll give you a little EM script that you're going to put on your remote borders. And that EM script is going to allow you to do the Wake on LAN across SDA transit. So I have that script, but I don't hand it out because it does need design council approval. The next one is I want to kind of go back to the Wake on LAN, the startup VLAN. This is a lesson that we learned during one of our deployments. If you configure the startup VLAN inside of the GUI, if that interface ever goes to an L3 interface for whatever reason, maybe we need to add another node, another Fabric Edge node to it, that interface that had configuration inside the GUI goes layer 3. The next time we provision that switch, the Catalyst Center is going to try to provision some layer 2 attributes to it because that gets stuck inside the SDA database. So you have to go and you have to get that port back to a layer 2 port, come in here and clear that information out. The better way to take care of this is I have a little template here, a little script template. And what we do is we just look at all ports that are access ports, and then we go in the interface, and then we set the startup VLAN. And what will happen is when we go into the GUI, those will all be blanked out. So therefore, the SDA database won't have the startup VLAN in it, but the switch does have the startup VLAN in it. We can Wake on LAN our devices, and if that port ever goes layer 3, we won't run into a provisioning error when we do our provisioning. So we're going to move on now to wired authentication planning. This one's important to me. This is one that we should have figured out a long time before we ever start deploying SDA. It's important to know how you want your devices to authenticate to the network. And it's important to understand the differences between all the different authentication methods. So you'll see in here that I have machine or user, and then on the far left-hand side, I have machine and user. If you go into the Windows supplicant with PEEP MS Chat v2 and EAP TLS, one of the options is, do you want to do authentication for user, do you want to do it for computer, or do you want to do it for user or computer? Note that in those circumstances, when you choose user or computer, if there's no one there, if there's no one on the device, it's going to send machine credentials. As soon as a user shows up, it's going to send the user credentials. It does not send both credentials at the same time. It's one or the other. So some pros and cons around these methods. With TEEP, it's very easy to set up and deploy. Extremely easy to with MS Chat v2, extremely easy to set up and deploy. It's easy for me to tell an SOE device from a non-SOE device if we're using machine-based authentication. Users can share machines, and policy is based on who is logged in the machine. And it's as secure as your company's password policy. It works immediately after imaging, so I can image a box, give it to my user, and they're going to be able to get on the network quite easily. It's very easy to deploy through GPO and Intune. Some cons is that when we're talking about the user, it's very difficult to tell the difference between a BYOD and a SOE. So there are methods and techniques that we can do to tell the difference between a BYOD and a SOE, but it's added configuration onto ICE. Windows 11, if you're not familiar with Windows 11 comes with something called Credential Guard. Credential Guard does not permit the use of cached credentials. So what happens if someone logs into their machine, they're plugged in the network, Windows 11 will not permit you to send those cached credentials onto the network, so the user's going to get prompted again to log in. And that can be very annoying. And then user-based MS Chat v2 is considered less secure than other standards and requires some sort of Active Directory for ICE to be connected to. If it's Azure Active Directory services or it's on-premise Active Directory, ICE needs to be connected. When we talk about EAP TLS, some pros, it's considered more secure. It supports Windows 11 Credential Guard, so when you log in, the certificate's there, it uses the certificate. It's not considered cached credentials, therefore the user doesn't get prompted twice. The certificate enrollment can be automated with GPOs and Intune. The machine certificate enrollment can be done during imaging. The user certificate normally not done during imaging. And it's a good option for companies that don't have an on-premises Active Directory. Some cons, it requires, I say an internal PKI, but what I really mean is a self-managed PKI. So you need to have a PKI that you're managing, a certificate authority that you're managing. And then you have to be able to figure out how are you going to handle expirations and re-enrollments and make sure that's taken care of before we start rolling this out. Logging into a new machine can possibly cause a delay. So if we log into a new machine and we don't have a certificate on it, we need to make sure that we're handling that in the policy. How are we going to make sure that you get a certificate on a machine that you're logged into the first time? And my last con is you need a certificate revocation list. And your ICE needs to be able to contact the revocation list. So if you do revoke a certificate, we can deny them from getting on the network. The last one I'll cover is TEEP. TEEP is fantastic. I try to push TEEP to all my customers. Every authentication sends the machine and user credentials. That's on a reauth, that's on a new auth, that's on wireless, that's on wired. We will send the machine and the user credential at the exact same time. Sorry. The TEEP has been around since Windows 10 build 2010, I believe. So it's been there for a long, long time. We can evaluate the machine group and the user group. So my ICE policy might say the machine is a member of domain users and the user is a member of domain computers or whatever. But every single authentication, I can evaluate both at the exact same time. So to me, it's the best way to identify SOE and BYOD devices without needing extra configuration in ICE and extra profiling techniques. You have a choice of your inner method. So your inner method could be ETLS, it could be PEEP MS Chat v2. You could have a combination of the two. The user might be EAP TLS, the machine might be MS Chat v2. They both could be EAP TLS, but you get to choose the inner method. And then when we build our policies, they're based on did the user and the machine both pass authentication. If they did, Give them elevated privileges, they get access to what they need to get access to. Did the user fail and the machine passed? So if the user failed, maybe their certificate expired. So now I know it's an SOE device, I know it did TEEP, so we can go ahead and get them a new certificate. Same thing, did the user pass and the machine failed? Did the machine certificate expire? And then we have, did the user and the machine both fail? And if they did, they don't get any access to the network. Some cons is you have the same cons with ETLS as the inter method. Same thing with PPMS Chat v2. If PPMS Chat v2 is your chosen inter method, Credential Guard is still going to block you from sending cached credentials. Your users are going to have to log in a second time. Another con is based off the version of Active Directory that you have or Intune, you may find that you need to build your GPO on a box, export the XML, and import it. It's not really a con, it's just an extra step. So with that, I'm actually out of time. If anyone has any questions, if you want to talk SDA, advanced techniques, if there's anything I covered in here that you want more information, come see me at the Data 3 booth. I'm very happy to have a conversation with you. And thank you very much for joining me today at Cisco Live, and everyone, please enjoy the rest of your time.